Hey everyone, yeah, it's been some time. Good to be back. Let me quickly check if my audio is working fine and then we can proceed. I think the audio is still a bit low. Let me try and fix this. Hello. Yeah, it's fine. So in today's session, what we are going to be doing is walk through something called Farcaster Hub Monorepo, and it is Farcaster is a decentralized, sufficiently decentralized social media protocol. It allows you to run hubs, and it emits a bunch of events for every sort of a user action that is performed, such as casting, similar to tweeting, or like reacting to a particular cast and so on. You can read the specifics at farcaster.xyz and on their GitHub, the protocol specifications. It's a pretty cool way where you can generate your Farcaster ID and your Farcaster name, a key, etc. on a smart contract on chain, and then use that across clients to basically get all your social media profile in one place. So I'll quickly draw the diagram as to what we understand so far. So there are a bunch of Farcaster hubs. Like in the world of Web 2, consider this as the backend server of, let's say, Twitter or any social media, emitting all the events of user actions, such as, let's say, user casts, like tweets. So it will emit a event called cast add body, and so on. Now the beautiful thing about Farcaster and an entirety of Web3 is that anyone can come in and run these hubs, and all the different messages and actions emitted by the user are available. So these are a bunch of hubs that are continuously emitting streams. Event streams are being emitted. If what I am saying does not make sense, please make sure to go through farcaster.xyz and read through their protocol specifications. So the verbs that are present in Farcaster are essentially of 4 types. One of them is going to be your message. Inside message, that there are multiple types. One of them is going to be your cast, one is a reaction, one is link, then you can verify your ETH address and so on. So these are the different types of messages and subsequent events that are emitted. You can go through these and make yourself familiar before joining for this video if what I'm saying does not sound very familiar. So now each of these hubs are emitting event streams. These event streams are messages of a certain type. Cast, link, user profile, etc. What we are going through today is something called Shuttle. So it's a library created. It is essentially a library. Its objective primary objective is to subscribe to events coming from hubs and then write it to a Postgres database. Now, whenever such a structure appears, it's a classic case of event streaming and their processing problem. So, an overall template would involve something like this, that there is a hub. Let me make this circular as before. There is a hub. This is emitting a bunch of events. And there is something called a subscriber which listens to this. And what the subscriber does eventually is takes those events and puts it in some sort of a queue. Now this can be Kafka, but in this particular live package they are using Redis, so we will be going ahead with Redis. If you are familiar with Kafka, this will be something similar to a Kafka producer. Now once this is done, there will be the other side of this, which is going to be your some sort of a consumer. In this particular instance, it will be hub event processor. Within itself, it will call a message processor, which will like take in each event, figure out which message type it is, and then act accordingly, and finally interact with the Postgres database to do all the CRUD operations, which in our case might have slightly different connotations like merge, prune, delete, etc. This overall is the flow of a general event streaming pipeline and their processing, no matter where you look. Now on top of this, there are a bunch of other things happening with respect to the decentralized nature of this particular protocol. If I put here, this is a general pipeline for event streaming processing via some sort of a queuing mechanism. What is happening here is the events emitted by hub 1, let's say, these are E1, hub 2, this is also emitting events, These might be slightly different at times. The rest of the flow remains the same. But what is happening here is your consumer listening to hub 1 and in fact let me quickly make it. So what I was saying is that your consumer listening to hub 1 may process some events which are not present in the events emitted from hub 2. So there may be a discrepancy, like there may be an, in fact this is normally the case where E1 may not always be equal to E2. There might be some messages missing or stale, etc. In that particular case, event processor needs to run additional processes on top. Additional processes such as backfill, pruning, etc. We'll also look at this. So overall, there are two components. One is your general event streaming and processing pipeline that goes through like this. There is a subscriber, puts it into Redis queue. There is a consumer that listens to it, calls a message processor, puts it into Postgres. The other pieces, additional processes, to figure out which messages are like being emitted by one hub, which are not present in the messages available to another hub, and syncing both of them, like trying to sync as much as possible with the goal of eventual consistency. So these are the two pieces that we are going to be looking at in the code base. And sometimes devs come up to me and ask me, hey, how do you go through a completely new repo, like that library or package that has already been built out? So what I generally tell them is to start with the different types or interfaces that are present. That's the first thing that you should look for, to get yourself an understanding of the different data models and the different components in the entire repo that are interacting with each other. After that, the second thing that I generally tell them is to go from top down. First go into the highest level such as index.ts or app.ts file and look at all the imports and where they are coming from. So here in the Shuttle package itself, it does not have an app. It is open for us to implement, but it provides an example app which is an actual implementation and usage of the Shuttle package. So we'll be keeping an eye on both of these and looking at first of all the package and then its implementation as an example app and creating a flow accordingly. The third thing I tell them is to not read the code from top down, start reading the code but compress it first, and by compressing it I mean figure out what the different function signatures are. So in the current flow we realize that there is a hub and there is a subscriber listing to it. So without subscriber the rest of the flow will not happen. So the first thing that we'll do is dive into hub subscriber code base. Now by compressing it I mean just reduce this all and figure out what are the different classes and function signatures that are present. So now in this particular code base, in this particular module we have something coming in from hub node.js, Farcaster hub node.js, client readable stream, hub event type, hub result, hub RPC client. So these are all hub specific things that a subscriber will need to attach itself or listen to the hub. If you want to go deeper into the hub implementation given by Farcaster, you can go into hub Node.js, which is I think is a node implementation of the hub, and the kind of classes and methods it emits for you to pass on to the subscriber to be able to subscribe to it and listen to the events emitted. Let's quickly go through the imports. So this is, I'm assuming, coming in from hub Node.js. Today we are not covering the implementation of hub, so I just treat it as a starting point or a black box. Now let's get to it. First thing we need is a rectangle. Herein, a bunch of things coming in from hub. We'll just put in client readable stream, hub event type. I'll just shift this to the left. Why has the size become so big? Okay, that should do. Client readable stream, hub event type, hub result, hub RPC client. This is coming in from the hubs. We are not too bothered about it. Treating it as a black box and moving forward. This would all go into our subscriber. Next thing is error OK result from never throw. This is a standard, I think, library. Type safe errors for JavaScript. Fine. Logger typed emitter event stream connection from .event stream. Okay, so there is something called event stream connection coming in into the subscriber as well. Let's quickly put that up here so that we can come back and look at it later as to what exactly it is. But it must be some sort of a configuration or specifics as to how to connect to the event stream. Sleep. Why do we need sleep here? We'll figure out in the utils. There's a Redis client coming in and a hub client coming in from .hub. Redis client is also understandable since subscriber would eventually write to the Redis client. messing with me. Yeah, that's fine. Let's put all the hub related stuff here itself. Hub. What we have is a hub client coming in. Oh, this is so annoying. Why are you so fucking annoying? Ah, forget it. So these three things go into our subscriber. Now there is a hub events emitter interface that we have passed. There is going to be an event, and if there is an error, so we have done this to basically type safe it. Now the hub subscriber is a class that we are creating in our subscriber class. So this implementation left. We need a bullet. This should be good. Okay, I'll take care of the niceties later on. Somehow this is still not connected. Find to be extremely weird. Should be working. Now we see this is an abstract class. This is implemented by base subscriber. And finally, event stream hub subscriber is what just happened. I don't like draw.io. This is abstract, needs to be implemented as a base subscriber, which I think will have all the config and the basic setting for the subscriber class to operate, and finally we'll have the event stream of subscriber. This is what I think will be exported and eventually used in the rest of the package. Move it slightly to get some more space. Okay, moving on. Now we are seeing that there are a bunch of default event types: merge on-chain event, merge message, merge user improve, prune message, revoke message. These are the 5 event types that we have. Let's quickly put it here for reference. And depending on these 5 event types, the decisions will be taken. I can't get connect properly. Okay, so what we can do is take it a step further and actually start building out each of these classes separately. First one what I'll build out is your hub subscriber and see what are its core properties. How do I create a new one? Second is going to be your base subscriber, and the third one is going to be even stream hub subscriber. Sure, these are going to require a lot more space. What is wrong with it? Okay. Sometimes it just does not behave as intuitively as it should. It's quite painful. Right. Getting into the hub subscriber is the first class. Public read-only hub client. Okay, so it takes in a RPC client. It defines abstract methods: start, stop, get last event ID, which is a number or undefined, and a promise on top of it. Process hub event, it returns true as an abstract class, and finally destroy to stop the connection to the hub. Okay, this is pretty simple. You put it here and put in the 5 methods that it has. The 5 methods inputs hub RPC client, start, stop, get last event ID, and process hub event. Finally destroy. Pretty straightforward since this is an abstract class. Now the base subscriber. Slowly we are getting into the meat of things. It takes in a label, hub client, stopped, log, event types, stream, shards, shard index. Label, hub client, okay. Stopped, log, event types. Label that you can name a subscriber essentially. Takes in again a hub client coming in from the hub subscriber itself, which was taking in a hub RPC client. Let me quickly mute this. Stopped equal to true. By default, our subscriber is not running. Log event types. As we saw, it takes in an array of the different hub event types that we just discussed. So what we can, I think, define is a bunch of event types as an array, which this particular subscriber will subscribe to. Once that is sorted, then it takes in a private stream, a client readable stream of a particular hub event. Okay, so I think it takes in a bunch of event types and then it passes that to the client readable stream so that it subscribes to the particular hub for that particular event. Takes in a stream, total shards and shard index. Shards are still not clear per se. I think this will become clearer as we go forward. Client readable stream, shards, shard index. So the moment class is initialized, or whenever you initialize a new subscriber, base subscriber class, you need to pass in your label, hub client, log, event types. Total shards, shard index. It takes in the constructor arguments, the values passed in those arguments, and then assigns it to the class itself. First calls in the super, the methods of the abstract class, the constructor of the abstract class, value label, hub client, log, total shard, shard index, event types. Okay, so you can pass in specific event types. If you don't pass in anything, it will take in default event types and subscribe to all the events that are being emitted by the hub. Override the stop method coming in from the abstract parent class, which I think was stop. Okay, just a error method not implemented. So it's now overriding, and the stream is cancelled. Stop is set as true, which is I think also the default value. But when you start it, it will be turned to false. Login for stopped subscriber. Okay, this is just logging it. Destroy, if not this stop, this does stop. This dot hub client, that close. So this is just stopping the subscriber, but this is stopping the subscriber and closing the connection to the hub client as well. Private wait for ready hub client. Promise resolve this hub client, wait for ready date. Okay, so it waits, I think, 5 seconds for the hub client to get ready. Again, pretty straightforward. Stop, destroy, wait for hub client to be ready. Stop, destroy, which is your stop plus close. Wait for hub client to be ready. It's 5 seconds. Already sync start, then hub client ready. We wait for 5 seconds. If there is an error thrown, it logs the error and throw hub client ready dot error. This log info. If there is no error, it logs in that hub subscriber and the name of the subscriber is now connected to hub. Now what it does, it fetches the last event ID that it has processed. So when we are putting an event, there would be somewhere where we will be generating and assigning an ID to each event going into the Redis queue. So let us start. Pretty straightforward. From ID, and then if from ID this label found last hub event ID. So it's like it was processing a Redis queue, in the midway it kind of, let's say, stopped or crashed or someone deliberately stopped it. Then that particular queue would just remain there, and when you restart the subscriber, it would go back, first fetch that event ID and start processing from that point. So it gives in some sort of a state with respect to event processing. Okay. But this get last event ID has not yet been implemented, I would say. It is present in the abstract class, but it is returning undefined for now. Okay, from ID, else this no last hub event ID found, so it starts from the beginning of the queue. This is straightforward. Now subscribe params. Event type, this dot event types, you don't pass in, and go all the default event types go in. Total shards, how many shards you pass, shard index from particular ID. So let's say you did not pass any of these values, shards will be 0, index will be 0, so it will, I think, take in the entire queue. Not worry about the shards. Event types you don't pass in, it will just take in all the default 5 event types. And from ID you don't pass it, it will just start from the start of the queue, starting from beginning. Fine. So inside start we have from ID, then we get the subscribe params. Once subscribe params are found, we pass it to the subscribe request. Hub client dot subscribe, it subscribe params. So hub client would know which hub to connect. There would be somewhere where a URL would be passed or a default would be specified. Subscribe request you put in, then stream. So what you would get is a stream object. This login for subscriber, this label subscribe to hub events of the types that you specified for this shard index out of these total shards. Then you assign the stream to this particular class's stream attribute, and this dot stop equal to false. Stream on close async subscriber stream close, this is stop equal to true, stream null, because this is just closing the connection. So the stream would be listening for us close event being emitted from, I think, when you call manually. Yes, I think when you manually call destroy, it might be listening to this sort of a close event. stream on close void this process this dot process stream. Where did process stream come into picture? It's not here. Process hub event. There's no process stream. So all inside started it, passed in the subscribe request, subscribe params to the subscribe request. Then once you add the subscribe request and then client.subscribe, this .log.info, this .stream on close. Okay, so subscribe request taking in a hub client. Hub client would have a process stream method somewhere wherein the stream object is going into it. And you return okay stream. This is returning I think void. This dot process stream is coming in from subscribe request. And then this is what becomes subscribe request. Subscribe request has this dot process stream and passing the stream object to it. Or else if there is an error, just throw in an error, return it. Process stream is here, okay. So process stream takes in a stream. Okay. I made a slight mistake. This is not coming in from the hub client here. This is coming in from the class overall. So it's another method that is defined in the base subscriber class. Can close constructor, start, destroy, etc. Close this also, yes. So process stream defined as part of the class itself. This is what is process stream. Takes in a stream object. Let's see what it does. Client readable stream, just the clock.debug, hub subscribers, start processing, straightforward. While not, this is stopped. Okay, while this is running, if the stream is closed or stream is destroyed, await the start. So while the subscriber is not stopped, if the stream is closed or stream is destroyed, restart the system. So there are two things happening. One is your subscriber is running, within the subscriber there is a stream that is running which is connecting and listening to the hubs. So in case your subscriber part of code is running properly but your stream is closed for some reason, you are asking it to restart and then break. Once this stream is started, await constant event of stream, this dot process hub event. Okay, where is process hub event? Process hub event have we implemented? I'm just returning a true for now. This dot process hub event of stream. If there is an error, catch, return the status stopped. If this is stopped, hub event processing stream stopped. Else halted unexpectedly. Restarting in 5. Wait sleep. This dot start. Cool. What is not clear to me right now is process hub event we have not implemented anywhere. is just returning a true for now. Okay, so I think eventually this is the base class that has been written. Process hub event might be overridden by event stream hub subscriber. Let's get to the third class that I think is the actual class which will be used. Extends base hub subscriber, it takes in an event stream, Redis, stream key, Redis key, events to add, event patch size. Label coming in from base, hub client from base, event stream and event stream connection. Base was taking in a client readable stream, but this is taking an event stream connection. We'll have to find out where is event stream connection coming in from dot event stream. Okay, so we'll get to that. Redis client shard key log event types similar to what the base was receiving, total shards and shard index. So the new piece of information that we have here is this event stream connection and what exactly this is. Right, so we can move event stream to here. What is going on here? Actually, these are like 3 different classes part of subscriber, but a more accurate way would be connecting this with this and then yep, it's more of a sequential thing rather than parallel thing. Hmm. So we see that the constructor arguments that this one is taking is in addition to what is coming from the base class. Additional we have is event stream and a shard key. Event stream shard key. Event stream is coming in directly. Oh, come on. Here. I can improve this. Client stop log events. Okay, these are not functions. I should be organize this a bit better. Constructor. And it's true. Log, which is logger. Event types. Stream shards and shard index. Types. Total shards, shard index. Six constructor dogs and another one that is a client readable stream being directly assigned as an attribute value to the class itself. Herein it takes in label hub client event stream, label hub client event stream Redis shard key. These are three new ones. Additional constructor dogs. Event stream Redis shard key. Log event type total shards shard index. That's all present previously. So call the constructor of this parent class using super label hub client.client log event types total shard index and then additional event stream Redis stream key Redis key stream key and Redis key. Second Redis and Redis key. Takes in a Redis client, Redis key, and something called stream key. Which is being derived from the shard key. Redis key is host and shard key. So this is being derived from client dot host shard key. So Redis is being passed to Redis client. A stream key is being generated, which I think uniquely identifies a particular stream. This is which host. So for a given hub, event message and a shard key. I'm still not clear as to what exactly shard key is doing here. It will become clearer as we go deeper. Redis key is straightforward. I think it's just the host and the shard key. So okay, if I put it this way, okay, so it might be something like this, that there is a hub, its identifiers are going to be its host, like its name, or let's say URL uniquely identifies this hub. And whatever it's emitting, stream emitted, identified by a shard key. This part of the stream will go to a specific queue. This would be a Redis queue. Let's say shard key would be 1. Redis queue, shard key would be 2. So I think this might very well be a way to identify it. This is stream key, which is a hub 1, shard 1. So from hub 1 it is stream is emerging and going into Redis queue 1, while this stream key would be from hub 1 it is emerging and going into shard 2. This sort of structure is what we are looking at through the shard key and stream key. Stream keys would be uniquely identifying stream emitted from the hub going into a particular shard or Redis queue, and Redis key would be from Redis's perspective the host that it is receiving. Now this has just two functions. One is get last event ID. Okay, its functions are get last event ID. The other one is process hub event. Migrate the old label based key if present. Okay, get present this dot label. In Redis it is looking at get last processed event. Redis client would be having some method. Redis client would be having some method get last processed event, and then you're passing the hubs label. Okay, so this is Redis dot get last processed event with label hubs label. Then what happens? If label based key is greater than 0, label based key is greater than 0, this Reddit. Okay, so now I'm setting Redis's clients set last processed event is this dot Redis key, which is your host plus shard key plus label based key. So what I am identifying is for the Redis queue and the specific shard inside it, which is listening to this particular host, assign its last processed event as the key we just found. Label based key. So for this subscriber, to check for the last event ID that has been processed, we do this. So label, where are we passing a label? Label, I think in the base class we were passing constructor. Label is string. Okay, at the time of constructor it's being passed, and then the label is also being modified later on using get last event ID. Which is kind of confusing as to what exactly is going on here. Redis dot get last processed event this dot label. Set last processed event this dot Redis key and label based key, and then you await this dot label for this particular subscriber. Oh, I think this is for old label based keys migration, this piece. So basically get the label based key, and if it's an old subscriber using their hub subscribers label to create this key, they are putting it to 0. And yeah, set last processed event for the Redis key as the label based key, and then set the last processed event for this label inside the Redis key as 0, and finally they are getting the last processed event as for this particular Redis key. I think this is the migration piece of it. Let me read through this again. Redis dot get last processed event start label. If this turns out to be 0, this is not executed, then you just return get last processed event for this Redis key. This is clear. But if this turns out to be greater than 0, then what you do? Set last process event for this or Redis key as the label based key. Okay, these two lines are still unclear to me exactly, but we'll circle back to this. For now, I'll just take this piece for the latest code. That all you're doing is calling the Redis client and getting the last processed event for this particular Redis key, and that Redis key is the specific shard, which is holding the events from the stream emitted from the given hub client.host. Straightforward. Start get last processed event. This dot Redis key. Fine. Finally, process hub event. Process hub event. What this does? This dot events to add dot push event. Events to add, I think, is a okay hub event list. Events to add, I've not put in here. This is an events to add, which is an array. Events to add dot push event. Process hub event takes in the event passed into it. This comes in from process stream. Started the subscriber, connected, starts processing stream. Process stream takes in the stream coming in from the hubs, passes it an event by event to process hub event. Process hub event takes in and then events to add array. It pushes the event into the events to add array. If this dot events to add length is greater than this dot event batch size. Event batch size is 100. Event batch size is 100. Events batch size is 100. Let last event ID. Okay, for constant event, if this goes bigger than the batch size, for constant event of this dot events to add, await this dot event stream dot add this dot stream key buffer from hub event dot encode event finish. It's taking in the event. Okay, once it becomes greater than a batch of 100, it takes the event, encodes it using hub event dot encode, and converts it into a buffer, and then in the event stream it adds this. It puts in the last event ID as event.id. If there is a last event ID, then it tells Redis, hey, set the last processed event using this dot Redis key as the last event ID. This dot events dot add. Okay, so it empties that particular events to add array. So this is doing a batch processing of 100 at a time. That is now clear. That size. And what is going on here is event stream dot add this dot event stream. Buffer of event dot code event. This is clear. Then you loop over it. This is doing a batch processing and greater than 100 batch size. Nice. So herein what I need to find out is what is exactly is the event stream doing. Event stream and its functionality. Event stream, let's get to event stream. So we have done the hub subscriber. Event stream, you need to keep an eye out for one thing that I missed here is it takes a stream key. So event stream is taking a stream key and it's adding into that each particular event. Stream key. Okay, so it's for the particular shard. There will be a Redis queue identified by, I think there will be different Redis queues identified by different shards. Right. And it's just adding to whichever is assigned at that point. So this event stream is essentially adding here. Okay, so our diagram is now complete in this sense. It should ideally get inverted. Nice. It's going into the event stream and then that is adding here. Comes in from hub, taken a Redis client, pass that. Event stream adds it to the particular queue. Okay, so we have done one module for the subscriber till the event stream processing in batches of 100 into a particular stream, into a particular shard using stream key. I'll quickly grab lunch and I'll come back in about half an hour.